I talk pretty loud, but I am going to open up with a developers, 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 right? I mean, we're in the platform track, guys. We're about the developers, okay? So thank you for coming and listening to my spiel about Blockless, but I'm going to talk about something that's a little bit different than maybe what you've been hearing in the conference tracks already. A lot of us are using WASM. I hope a lot of us or all of us are using IPFS in some way because thank you, Filecoin, IPFS, Protocol Labs. This is, where we are in our ecosystem. Let me introduce myself a little bit more. I'm the handsome guy on the second block there, Derek Anderson. I run the tech here at Blockless. I used to work at some companies you may have heard of, PayPal, Walmart, eBay. I spent a lot of time really working in infrastructure and finding a lot of problems in there. 2014 happened, Bitcoin was great, I thought it was stupid. Walked away from crypto. Who needs a replicated database that's global and has consensus and a financial system? I was working at PayPal. Okay, so we're past that. Now we're in 2019, and I'm meeting some friends here. We're all worried about the same thing. So I have, and you can find them out in the audience here. Please talk to them when you have a moment. We've got Boudien, Liam, and Michael, and we all kind of came to a same conclusion. They're all working on crypto, trading, asset management, liquidity. I'm working on platform, security, infrastructure. Distributed systems suck. Community-driven distributed systems suck. They do. Why do people keep using AWS? Why do they keep using GCP? So we had to come out and we had to build something that was different. So Blockless is different in terms of what's happening with a lot of the infrastructure. It's the same as what you're hearing happen at this conference. We are a distributed computation network. We use a foundational purpose of WASM. It's portable, it's purposeful, it's intent-driven. We can push it to any platform, we can push it to any machine. We really don't care what's underneath. If you're IoT, if you're institutional, we can run a computation load on you. We have granular specificity in our network. And what that means is that we want to take the power, or the hurt and the pain of trying to push your computation to machines that require specific attributes. GPUs, CPUs, ASICs, FPGAs, anything that you need to kind of get work done. We also don't want to compete, because the one thing that really hurts the community and kind of hurts everything we're doing is silos and sandboxes. So Blockless is really set out to be a network of networks, a joiner of joiners, and we want to make sure that developers can connect to Ethereum. You can connect to Polygon. You can connect to BNB. You can connect to Cosmos systems. Just bring your workloads to us. But what makes us different and what makes Blockless special? So you already heard me say distributed computing sucks. If any of you have tried to run a community-based network, you're going to run into problems. And the biggest problem is nobody wants to use your computer. Who has extra computers at home? Just raise your hand. You got an extra computer at home that's not doing anything? A lot of you do. Now look at somebody who has their hand up and tell me you'll run a production workload on the computer sitting in their basement. You won't do it. Why won't you do it? It's not reliable. There's no resiliency built into the network. There's nobody helping you determine that your payload should actually run on those machines. So what does cost-aware scaling actually mean? Looking for the spare compute in regards to those functional needs and finding a way to maximize the compute per dollar. Finding dependable, notable, but yet maybe not modern nodes. A lot of us have machines that are not of 2023 capabilities. So let's kind of dive into some specifics. And the place that I got a lot of these stats are probably one of the best places you could find them. Steam. Everybody plays games, and this place takes a lot of statistics from everybody's computers. So let's take a look at what we're actually dealing with when we're trying to launch a community-based compute network. The number of CPUs in a consumer-based computer goes from 2 to 4 to 6. And if you go to Steam, they'll take you all the way to 42 cores if you want to see if somebody's running one of those at home. It says 0%, by the way, so don't waste your time. So look at this. 2 CPUs still take up 8% of all of the home computers. That means that if you're running a workload on that machine, you likely, as a distributed compute network, only get 1 core ever at any time, or you're going to tank that user's machine and they'll never want to participate in your network again. But then let's look at the actual speed differences between these machines, right? So if we just look at the low end, we go from 2.3 gigahertz to 3.3 gigahertz. And that's about an even distribution across the entire Steam network. There are a bunch of different speeds if you want to go look at like the minor 6%ers, but these are really like the top 3 distributed buckets. So that means that your top of the line home computer that somebody may run your network on is 22% more efficient than the slowest computer on that network. But are you going to penalize the person who has the slower computer for participating on your compute? It doesn't make sense, right? It probably makes more sense for you to allow your customer to go ahead and pay for compute at a different rate. We also want to kind of look at what it means for community compute networks to come online. So here's like a quick snapshot from 2005 to 2011, and what makes this kind of like the why are we looking at this data? Because in 2010 and 2011, India and China eclipsed the US for total PC ownership. That's just 2 countries. Now, they do have the largest populations, but let's consider that the rest of the world starts to come online at a rate this fast, and they have nothing but spare computers to recycle in the next 10 years. So who really needs cost-aware scaling, and really kind of who can be enriched by this? So when we've kind of gone out and we've done our discussions with people and we've had talks with those that are kind of looking for this, it's really a cost sensitivity and a research that are kind of really our top tier customers. You've heard a lot about scientific and DSci in this conference, and those are really the people that kind of have the highest benefit from this because they really have fixed ROI. So by being able to fill the compute across the world, we can actually enrich the scientific community. But there's also hobbyists. So a lot of people don't have access to kind of the things that are on the network. And there are also developers who don't have kind of the enrichment of being able to access AWS and GCP. And they don't have the money to access those. And they don't necessarily need the fastest institutional machines that are running on the current Web3 networks, nor do they have enough Ethereum to launch a contract. Cost-aware scaling kind of benefits this by decoupling all of the problems with the blockchain, but looking and filling spare compute. And so you might think about what can you do with cost-aware scaling in your own project. So by using Blockless, you get the ability to kind of deploy with less forethought. You don't have to pay up front for a specific compute block that you're not going to use because we are function as a service. But we will help you scale so that we can fill your footprint based on your customer use. We'll find capabilities within the network that kind of meet your compute load. And I don't want to go into a bunch of semantics on how we do that because it's obviously very verbose. But we will actually try to fill, again, using IoT, using specialized machines such as Android phones, using Jetsons on the edge, finding where we can put your workload. Having dependable results that come back in a timely manner and a fairer price. So we'll get into like how we kind of start to rank the nodes that are doing compute because we kind of just don't let them sit off on their own. And so let's kind of talk about how we accomplish this because we are currently in testnet today. So our protocol enumerates the capabilities around the network at execution time. So that means that this is completely dynamic. You connect to a libp2p node and you send an execution request in. We use Gossip Sub protocol. We notify all the nodes that are in the network, and we start your compute. We use a chatter-based model because what it helps us do is actually self-identify those machines that have capabilities. We don't have to keep an entire network or a log of machines and addresses and try to find those machines. We let them find the workload. The nodes are then entered into a capabilities matrix, and we randomize and distribute among those, and I'll talk a little bit more about that as well. But I kind of want to show you, what the bread and butter of this means, kind of for a developer. So if the audio works, I'll let that handsome guy down in the corner kind of continue.
All right. so here we are at dashboard.blockless.network. And as you can see, I currently don't have a crypto wallet installed, so this will be what the page looks like if you come and you don't have one installed. Go ahead and pick which wallet you would like to use depending on the network that you want to participate in. We don't currently take payment, so you don't have to have coin. This is simply used for authentication and identification of your functions on our network currently. Press install, follow the install instructions on the wallet that you chose. Pause this video and head on back when you're ready. Now over here, I'm going to go ahead and activate the Kepler wallet. I'll go ahead and refresh the page. And now we have a connect button. We'll hit the connect button for a wallet. We'll be asked to sign a sign-on message, and then we'll go ahead and get inside the dashboard. That easy. Now that we're here, we can hit the create function button in the upper right-hand corner. And we will need to connect our GitHub. So we'll go ahead and add our GitHub account. I'm going to go ahead and add it to my personal repository, the function that we already have, or we can start with a simple use case. So here's Hello World on the dashboard. Let's go ahead and launch this one. We'll go ahead and give it a name and hit create. Now we're going to wait until the function builds and deploys. Depending on how big the function is, it can take 1 minute to 2 minutes, and then we'll just hang out.
This is actually happening in real time. As I'm recording this, we're building a WASM file, deploying on the IPFS network, and then we're going to push it out to the Blockless node network and execute it.
It says it's deploying, and now it's deployed. Let's go ahead and hit this invocation URL.
And it's that easy again for the developer.
Hello world. All right.
So that looked pretty simple, but let's go ahead and actually walk through everything that kind of happened in that to make it kind of magical. So we enumerated all of the nodes that were on the network when we went to execute the hello world. They were entered into the selection matrix, and then the selected matrix keeps track of result rankings over time for the life of the node. And we rank them in a couple of different ways. I'll get into that too. They're a little novel and maybe weird for this segment. We do a simulated annealing process based on what your specifications are for that. So what I really mean is you tell me what you want your payload to do, and I'll go through all of the nodes in the network, and I'll simulate if they can actually execute this at the cost that you're looking for, and if they can, I'll put them in the matrix. And then we go through and we do a pseudo-random fashion of a distribution across the network so that no node knows it's going to execute your payload, and it may not be the same node that executes your payload twice. There may be multiple nodes executing parallel payloads or sequence payloads. We don't want them to know what work they're doing. They're shuffled, and then we do a Latin distribution algorithm against the matrix, selecting maybe RAM, CPU, storage requirements, and we kind of just magically fit your workload into that matrix. But then we do some kind of cool things after the nodes complete the work. We do this ranking operation. So we actually want to discern the quality of the nodes, like I mentioned. Maybe your mom and dad have an extra PC sitting in the basement and you want to earn a little bit of money on there while it just sits there. But it might not be the best PC, and it might not be the fastest one. So how can we actually determine what kind of quality of compute it does? So if you're familiar with chess, or maybe basketball fans, Boston Celtics, everybody, we have the ELO RPAD ranking system. And this is a one-to-one versus match rank system. If you play PvP games, Fortnite, any shooter games, you're also using this algorithm without really knowing it. What it does is it matches up characteristics of two players and identifies a ranking algorithm for one that supersedes the other. It trends towards infinity, so it never stops. Ideally, what this means is that a node could upgrade over time and become better than it was yesterday at doing the same tasks. But then we also kind of want to be able to grade nodes without penalizing them across an even ranking playing field. So we employ another kind of algorithm called the NASCAR ranking algorithm. So if you ever watched races on TV, this is kind of exactly the same kind of thing they're doing to determine who's winning in a pole position. But we apply this across the entire network so that we can get a 0 to 100% graded algorithm on what the machine is doing. This means what it's returning, how fast it's returning, if it's correct, if it falls offline. A bunch of different attributes are entered into this and then graded over time. So what other kind of things is it about scaling? And as I mentioned, we look to fill the capacity on the network itself. So based on how your workloads are running, what capabilities you need for those workloads, if you need GPUs, if you need specific hardware, ASICs, specific crypto algorithms, we enumerate that. We also have a plug-and-play extensibility system for our Blockless. So you can run your own node, you can use a CGI or a DLL interface, and you can extend that node. And then we can advertise those capabilities to the network, and you can actually provide specialized services to the network and earn based on that as well. So how can you get involved in Blockless itself? You can start building on Blockless today. So we are in testnet, we are open, that dashboard that you see, and you can go to it. You can actually fork our repos. We're open source. I'll have a bunch of links here at the end of the slideshow. You can get started building today. It's WASM based, but we do have some things around the corner that we're really excited about, and so make sure you stay tuned. You can extend the nodes. You can submit extensions and plugins. We do have developer tools to test as well. We have a CLI. We have SDKs. So there's a bunch of ways you can actually get involved. And how do you learn more? So you can check us out at blockless.network. You can check out the docs, blockless.network.docs, pretty easy. Follow us on Twitter. And then you'll find all the links as well to our GitHubs, our sub-GitHubs. We've got a ton of projects. Come and help out. And I think that's it for me today. If there's any questions.